So the final answer is FF. So your final answer for D0 is equivalent to $0.0000 B to FF because of the bytes only need to be replaced. That's my final answer D0. You cannot just simply put D0 is equivalent to FF. That is wrong. Because it needs to have the whole values before that. Kalau you kasih saya jawapan D0 data register only for 2 digits, that is not a register. I don't know what do you put. D0 to D1 must have 8 digits for hexa. Do not forget that. And especially the symbol. I tell you so many times, you need to represent the symbol. If you want to write hex, put the hex symbol, $sign. Else I'll consider it a decimal number. Decimal number is totally wrong. Okay? Alright. So I give you the ori.log. You can simplify it by yourself. You can, because it's very easy over here, the concept is that. Okay, let's move on. Now, for exclusive OR, you can do it by yourself based on the truth table only. So we just look at the last one is not. Not is this code. You write down that one. Not for that one. Write down the codes text there and run it. Try to figure out how the result changed accordingly based on the truth table. Now start with not. It's not very simple. The result is there. Then you have to compare based on your writing because you have stability in that set. Only size bytes are there. I give you bytes. You have to invert whatever bit that you have over there. Yes, you must have this register. So 2D convert to binary will be 0, 0, 1, 0. D is 13. Yes, 1, 0, 1. Okay, not means you have to bar it right now. So now change it. 1, 1, 0, 1, 0, 0, 1, 0. So the final answer is this one. This is D. This is 2. So your final answer at the end, D0 is equivalent to $0,000,000 A to D2. That's the final answer. Okay, faham eh? Alright, Boolean is very simple. Now move on. After not is shift and rotate. Okay, shift and rotate got 8 of them. 8. You have 8 of them for the shift and rotate. Shift, you got 4 of them. Rotate, you also have 4 of them. So means shift. Shift means that you are shifting. You are shifting it, whether to the left or to the right, the bit. Rotate means you are rotating it, the bit, inside the registers. Okay, let's look at the table first and then we go for the syntax. The opcode is this format. So this is the concept for arithmetic shift left and arithmetic shift right, logical shift left and logical shift right. So let's look at the first two first. Arithmetic shift right and arithmetic shift left. The first one is arithmetic shift left, which means that every time you shift the bit to the left, you are going to copy 0 to the lower side, which is the least significant bit. You shift once, it will move. And then you shift again, it will move again accordingly to this one. This is a table. Same as the arithmetic shift right. Every time you want to shift to the right, you are going to copy the value from the MSB here, inside here, and then you shift. So let's look at the syntax first. Let's try the syntax. So that's the concept. Okay, now look at the first one, the concept on the syntax. So right now try arithmetic shift. Copy that one first. Origin 1000, yes, sorry. Pandai sekarang So right now, the command asks you to shift to the right 2 times because of the number #2. That means that you have to shift 2 times and then finally you get the last answer. If you want to shift that particular bit right now, so you have to refer back the table that I showed you just now. Refer the table first and then you can do the shift operation. #2 is that means that 2 times you have to shift. Sorry? Yeah, this is the only form, yes. Correct. The first number 2 is telling you how many times you need to shift. So now you have to shift twice. Look at the table first. How the shift to the right take place. Look at the table, how it works. So So I show you once, eh? I show you once. Now look at this one. D1 for byte, eh? D1 for byte is equivalent to F0. Okay, so far, okay? I move it to binary, I change it to binary, means that it's 1 1 1 1 0 0 0 0 in binary. Okay, so far, okay? That command is asking you to shift right 2 times. So look at the table first. The table indicates that for arithmetic shift right, the process will be done like this. Once you shift out, you are going to have the first MSB here, the value over here will be shifted to the first one, and the last number will be go to the X and C CCR code. What does it mean? So once you want to shift, the first time you want to shift, you are going to shift the whole thing to the right. You are going to copy this one first. 1, that's the first value. Then you copy the whole one to shift up. 1, 2, 3, 4, 0, 0, 0, 2. Your X and C is equivalent to the last one. 0. You see this one? It's copied. That's the first shift. It's not finished yet. XB is CCR code, status register. Extend and carry. The one that we learned yesterday. Look at this one. Arithmetic shift right. Look at this one first. The MSB value will be copied to the first one and shift. The last one will be copied to the X and C. So now the first shift is this one. My question asks you to shift twice. So you have to shift again. So let's look at the second shift. Copy again number 1, because MSB is 1, right? So copy again number 1. So you have how many 1? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 0, 0. Now X and C is equivalent to this number. Out from the thing. So your final answer now is F C. This is 14, right? This is 12. C, A, B, C. The final answer D0 is equivalent to 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, F, C. Is it the same one with the simulator? Huh? Yeah. Alright. Same one? Or you want me to repeat? So every time you want to shift, you have to refer back to the table. You also can refer the X and C after the operation must have, we have 0 over there. The value is 0. Because it's based on that particular table. The concept is like that, the process is like that. So if I ask you to shift 5 times, means that it's hash number 5, so you have to do it 5 times over there, you get the final answer. So okay? No, okay. Alright. So let's look at the second one. then finally you get easy. That's why you can try. If you shift up to 7 times, for this example, if you have this MSB is 1, if you keep on shifting to the right, finally the answer will be all 1, 1, 1, 1, 1, 1 is the logic, right? So you keep on putting 1. If you're starting 0, you shift 0, and then it will be all 0 at the end, right? So you're shifting it, you tolak it. Shift. Okay, let's look at the second one. Arithmetic shift left. So the same one just now, changing this one to arithmetic shift left dot 5. Change it and run it. Now you have to read. Now you have to read on your paper how it changed. Okay, now the command is like this. I want to shift to the left 2 times. Now you have to refer to the table. Try shifting by yourself. Looking at the table, try to shift. You see the table, ASL, look at the table and shift it by yourself, get the last answer. There must be as the same with the simulator. Look at the table for ASL. ASL shifting is different. ASL, now the process is different. Look at the table. You have to refer to the table, then get to the shifting process. The shifting for ASL is like this. The shifting for ASL is the top one. Shifting ones, you have to shift, you have to include 0 and then shift. You have to read twice. ASL is on the top of the table. So you have to read on your paper how to shift twice. Accordingly from that one. If you understand 2, you should not understand the whole figure over there. It's the concept. ASL is that one. You have to shift from the right to the left. You have to start push 0 and then push the rest. That's it. We up. Will be complete to SNC. Shifting it to the left and make sure the first number will be changed to 0. You are putting 0 and push the rest. The MSB will be copied to XNC. You have to read on the paper that you can see. Every time you look at the questions and you can read over to understand that one, you can understand the whole 8 sequence. Just how the command is different, but the function is the same. The command is different. It's the same with multiplication and the arithmetic. Alright, let's look at the answer just now. ASL got I 2 times. So let's try. Okay, arithmetic shift left 2 times D1 byte size. So let's try now. D1 byte size is F0 again. F0 means 1, 1, 1, 1, 0, 0, 0, 0. So this is the binary numbers. So now you have to do the arithmetic shift left. Left, right? Left, 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 left. Left here, sorry. Left over here. The table say for arithmetic shift left, left, 0 will be added to the list and shifted to the left. The most significant bit will be copied over X and C condition code. Alright? So right now, from this value, you have to shift twice. Means the first shift, you have to shift 0, put inside here. So you have to shift everything out. This one will be copied to X and C. So now, X and C is equivalent to 1, right? So are you shifting it? You have to put 0 here. This is the first one. And the rest one is from here. So 0, 0, 0, 0, 1, 1, 1. Okay, the first shift. Then you shift again. So you put another 0, put it again, 0, 0. So then you have the rest 0, 0, 0, 0, 1, 1. Your X and C is coming from here. X and C is equivalent to 1. So you divide again, not divide, you just want to know the answer. This is C, C, this is 0, which is 16. And the final answer for D0 is $sign 1, 2, 3, 4, 5, 6, C, 0. Okay, so if you look at the table, if you understand 2 of them, if you understand these 2, you should know to answer these types also. You can look at the data, the table, and then you understand it. Which one needs to be shifted, which one needs to be put on 1 or 0. Okay, faham ini? Okay. So look at now at the rotate. Rotate is a bit different. Now we are concentrating on rotate. Okay, rotate, Rotate now is a bit different because it's a rotating. You have to use the figure, the value back to the register. So now we are looking at the first rotate left, rotate right, rotate XL, logical, rotate right, rotate X right. So look at the concept first. Okay, now we are going to run the command and you try first, get the same answer. If you get the same answer, means it's totally you understand. And now, look at the command for rotate.